Hello everyone, my name is Ahmad Nasruddin bin Abdul Talib, student ID EP0107521. So for this video, I will show to you guys on how my working solution for this midterm project. Without further ado, let us proceed. So this is a overview of the question for the midterm project. Home security system. A home security system is designed so that it sends for input lines A, B, C, and D. Line A is the secret control switch. Line B is the motion detector attached to Windows. Line C is from a battery powered clock, and line D is connected to a magnetic sensor to detect open doors. So for this is a interpretation from before. So inputs, we have four inputs, that is inputs A, B, C, and D, whereby input A is control switch. If control switch is off, the logic is 0, otherwise is 1. Input B is motion detector. When there is no movement, the logic is 0, and if there is movement, the logic is 1. The third input is clock, whereby it will be off. That is logic 0 from 12 am to 6 am, and other than 12 am to 6 am, the logic is 1 for the clock input. So the fourth input is magnetic sensor, whereby when the door is closed, the logic is 0, otherwise when the door is open, the logic is 1. So this is three condition that is will produce logic 1, that is function 1. If these three conditions satisfied, so the output will produce logic 1. So the first condition is when there is movement, that is B equal to 1 and control switch is off, A equal to 0. So the second condition is the door is open, D is 1, and after midnight, whereby 12 am to 6 am, C equal to 0. And when the door is, the third condition is when the door is open, the door is open is D equal to 1, and the control switch is on, is A equal to 1. So from this interpretation, we can conclude the truth table for the output column. So to get this value, so we interpret A equal to 0 and B equals to 1. A equal to 0, B equal to 1. So this is the final output for first condition. And the second condition is C equal to 0 and D equal to 1. C equal to 0, D equal to 1. For this four output 1, 1, 1, 1, and the final condition is A equal to 1 and D equal to 1. So this is the final output. A no. A equals to 1, D equals to 1. So from the two table, we can proceed to the timing diagram uh, for for the next slide. This is timing diagram based from the truth table. As you can see here, we have four input A, B, C, and D, and this is function of the output. For example, if we take 0, 0, 0, 0, so the output is 0. 0, 0, 0, 0, so the output is 0. If the input is 0, 0, 0, 1, so the output is 1, 0, 0, 0, 1, 1. So for the final, 1 is 1, 1, 1, 1, so the output is 1. So 1, 1, 1, 1, the output is 1. So this is how we draw the timing diagram from the truth table. So the question number 2 is to list all the minterm or maxterm for the system and write the canonical SOP and POS forms. So for the minterm, I take the logic 1 from the truth table. That is minterm 1, 4, 5 until 15. So this minterm 1, 4, 5, 6, 7, 9, 11, 13 and 15. So this is the final minterm. To get this canonical SOP form, we need to change from term into alphabet ABCD. So why this have bar and some that did not have bar? Because for example, minterm 1 is 0, 0, 0, 1. For canonical SOP form, if the zero if the input is 0 value, so the alphabet will have bar or apostrophe. So that is how we get A, B, C, D bar. Other example, if we take 11 is 1, 0, 1, 1. So the output is 1, B bar because 0, C, D. So for the max term is I take 0 value from the truth table. 0 value from the truth table. 0, 2, 3, 4, 8, 10, 12 and 14. So this is the canonical POS form. So for the canonical POS form is opposite from the canonical SOP form because for example 0 value max term 0 is 0, 0, 0. But the alphabet form is A plus B plus C plus D. For example, if we take 12 is 1, 1, 0, 0. So the form is A bar, B bar and C, D. So this is my solution for minterm, maxterm and canonical SOP and POS form. So question 3 is we need to implement the system using a few logic gate as possible. So to do this, the easiest solution is to do from KMap. KMap is written based from truth table. As you can see here, input A, B, C, D. If value of 0, 0, 0, 0, so from the truth table is 0. If I take 1, 1, 0, 1, the value is 0 is equal to 1, 1, 1, 1, 0, 1 is 0. So this is how I draw the KMap. To get this form, we need to group value of 1 that is adjacent to each other and get the largest possible values, largest possible group. As you can see here, this 4 value is 1 that is adjacent to each other, and this also. To get this AB, we need to find the input number that is not changing and constant. As you can see here, input AB is 0, 1. Is same from this column to this column until here. And same goes for CD. The CD value is not changing input from above to below. And AD I get because A is not changing 1 to here and B is changing 1 to 0. So we did not have to take B value, and this CD 0 to 1, C is changing but D is not changing. So that's how we get AD. To draw the logic implementation, I need to get the simplest form from here. If we take this form, we can get 7 logic gate. But if I factorize D and get C bar plus A, we can get 6 logic gate. So this is my final draw of logic implementation. So for my KMAT before, we can identify the hazard. Hazard can happen if uh, value of one that is adjacent to each other but is not group. So hazard can happen. So from the truth table, from the KMAT before, this 4 value is adjacent to each other but I did not group them. So hazard can occur. To fix this, we need to get the form here. So I get A B D because B is not changing 1 1 and D is also not changing. So this is the new form of free hazard. So this is a timing diagram when the hazard happen before I add this form. So as we have 9 input A B C D, A bar B C, D bar plus A bar, and D bracket C bar plus A. So for this final output, as you can see here, is different from the previous timing diagram here. The value of 3 here and 9 here is different for the hazard diagram. As you can see here, the value is 1 and this value should be 1. This 3 value is 0 but the hazard timing diagram is 1 and this value should be 1 from the previous timing diagram. So for the question 4, we need to draw hazard free circuit only using universal gates. From to get there are 2 ways to draw universal gate. The first one is using De Morgan theorem from Boolean algebra, and the second one is using by modifying the circuit. So I use second method to draw this hazard free circuit. So this is 3 gate I use. For NOT gate here, you simply change into NOT gate, and AND gate here we use this gate and all for the hazard free circuit. So circuit simulation, I will show you guys my simulation using logic L1. So from the so we need to verify the logic diagram. So from the truth table, if the input is 0 0 0 0, so the output is 0. If the input is 0 0 0 1, the output should be 1. So I turn down this input, so the light is bulb. That means alarm is ringing. What if I take value 1001? So the alarm is ringing. And one example, 1010. 1010. The alarm is not ringing. So that's all from me. Thank you.